Hello, my name is Laura Waldron, and today I'm going to discuss the concept of machine translation. We will look at what it is, why it's important, some issues with machine translation, some types of machine translation, the tools used for machine translation, and other related concepts. Let's get started. What is machine translation? Machine translation employs artificial intelligence to translate between a source language and a target language. It is a natural language processing technique for converting text. The idea is to map the text from a source language, for example, English, to a target language, for example, Spanish. Machine translation is done only with machine learning tools, such as artificial intelligence. Automated translation is a similar concept where the steps of machine translation are automated. It's a subcategory of machine translation. The goal of machine translation is to preserve as much of the meaning as possible from one language to another by looking at all the words in the sentence to communicate the full context. So, why is machine translation important? There are many reasons, but specifically in terms of global communication, machine translation enables global communication in fields such as healthcare, education, business, and politics. It allows international companies to translate from country to country and provides accessibility of global information to multiple different countries. So, if a company works in multiple different countries, machine translation can enable text to be translated from one country to another with all the context included. Finally, it is a useful tool for multilingual content and social media, just keeping the globe more connected in terms of communication. The idea of machine translation was formed in 1947 with the creation of rule-based methods, or RBMT. Machine translation techniques fall into two different categories: rule-based and corpus-based methods. The rule-based methods employ written rules and dictionaries to confirm translation. So this means when the text is being translated from one language to another, the researchers refer to those written dictionaries of both languages to translate. However, writing down rules takes too much time, and languages change very consistently, so rules tend to change as well, meaning that it can be difficult to maintain the rules, as every time, every year, rules need to be updated, more words need to be added, context changes, etc. So, as a result of these challenges, corpus-based methods were formed to prevent this. Natural language processing researchers worked on creating corpora for machine translation. Three types of corpus-based machine translations have been employed. The first is statistical machine translation. There's also example-based machine translation, and the most recent addition is neural machine translation. Statistical machine translation is where machines automatically learn their knowledge from a data set rather than using written rules. So all of the rules of the language are compiled into one data set, and then the machine uses that information to translate from one language to another. This allows more easy updates, but it's not the best method. The example-based machine translation is used in computer-aided translation systems, and its goal is to look at sentences that are similar in the corpus. So it uses different examples from different languages. The most recent machine translation method that's corpus-based is neural machine translation, which was proposed in 2014 and uses deep learning technology to create a neural network for machine translation. Recently, this NMT, neural machine translation, has been the primary target of research and expansion across the globe. Another machine translation technique is hybrid, which combines the rule-based and statistical or neural methods to provide the best of both worlds. Neural machine translation, or NMT, is a more recent machine translation technique. So it was created as a result of deep learning technique advancement and neural networks. NMT uses sequence-to-sequence models, so it is different from statistical machine translation by building one neural network to maximize the translation performance. Its architecture is an encoder-decoder structure with attention mechanisms included. The source sentence is encoded into a vector, which is then decoded in the second part of the translation. The attention mechanism is there to allow the model to figure out which words require the most emphasis in both the source and the target language. The goal of the neural network is to translate the entire sentence so the context can be preserved rather than translating single words and losing the meaning. Researchers have recently been exploring various models to perfect this encoder-decoder approach. The most practical benefit of neural machine translation is that it uses only one model rather than different models for different languages. All languages share some baseline similar features, so NMT strives to use those features to make the translation much simpler by putting them all into one neural network. Transformer models such as BERT and GPT are a common application of NMT as they are currently being used and updated. The goal of NMT is to produce more natural, fluent, and contextual translations by treating the sentence in its full context and figuring out the best ways to translate meaning from one language to another with different contexts. There are currently many technologies available for machine translation. Practically, machine translation apps are really good because they can provide consistent content to users and can be used on mobile devices such as phones or iPads. So, the first tool is Google Translate. This one is probably the most common machine translation. Google Translate is a neural machine translation which is based in a multilingual system. It's extremely common, it's free for a lot of translation, and it involves a very high accuracy. Furthermore, Google is globally known, so many users are already familiar with the software, which makes the platform easy to use. DeepL is known for its high fluency and accuracy in translation. Unfortunately, it does cost more than Google Translate, which makes it not as convenient. It also does not have a mobile app, which is a downside. Microsoft Translator can be employed in Office, Teams, and Bing, and also includes a mobile app like Google Translate. It is more used for translating conversations in websites, such as live Teams communication or Bing searches. Amazon Translate is another cloud-based service for real-time translation. It also does not have a mobile app and tends to be more expensive with a lower accuracy in comparison to Google Translate. Other tools include open source tools like Marion NMT, Open NMT, and Hugging Face Transformers. These tools are more useful for researchers and developers to learn and play with translation, and not so practical for the everyday person to use and translate. So there are several challenges in machine translation. First, there's the challenge of ambiguity, where one word may mean multiple different things, or different words may mean the exact same thing. For example, in English, the word bark could indicate the bark of a tree, or it could indicate a dog barking. But if you were to translate that to another language, such as Spanish, there may be two words that could be used, one word for the tree bark and one word for a dog barking. Second, the linguistic rules in different languages change. Let's talk about the placement of adjectives. In English, you would put an adjective before you put a noun, typically. So, for example, beautiful car. In another language like Spanish, the adjective actually comes to the right of the noun, for example, coche hermosa. This could cause a problem in translation. Third, certain poetic texts may cause a problem as the meaning may not be literal, but could be figurative instead. For example, if I said she is busy as a bee, you would think in English that that means she's working very hard. She's very busy. But in other countries, they might say, well, is a bee busy? Like what does that mean? They might take it literally. In the same way, if you said piece of cake in English, another person from a different country might say, well, I don't understand. Where's the cake? Why isn't that literal? Fourth, the contextual understanding changes depending on the culture. Idiomatic expressions may not be understood in a different culture. The meaning of the sun sets could be a positive or a negative thing depending on the person. It could indicate hope, it could indicate sadness, it could be the beginning of something, it could be the ending of something, all depending on the context of that culture. Um, Another issue is different kinds of documents, such as legal texts or medical documents, or even government or educational texts, which may require a different, more technical vocabulary than just normal corpora. So, for example, in the healthcare field, there are lots of terminology that's used for different medical conditions, for different drugs, which some countries may not even have experienced those medical conditions and thus don't have words for them. Finally, some languages, kind of to piggyback off what I just said, some languages are not as well developed, meaning their corpora may not parallel the more expanded languages. So, for example, some countries may not have words for medical terminologies or legal terminologies, or maybe even words as simple as grass and trees if they live in a place like Mongolia or Africa where there may not be um, the kind of flora and fauna that we have in America. So it really depends on the context of the culture. So in the future, machine translation could have a lot of directions. First, we could expand machine translation to translate more than just text, but to also translate videos, speech, or images, to input multiple different models at the same time, along with text so we can preserve the context. Second, it could be really good to work on translating between languages that have not been trained upon. So zero shot translation is where a model is trained on two languages, for example, English and Spanish, and then is employed on a model that the corpora has not trained upon. Some languages also have sparse resources and do not have an extensive corpora already built, so despite several methods proposed to fix this problem in the field of deep learning and machine learning, it would still be important to improve the quality of some translations where the language are less developed by finding ways to build out the corpora, to add more words, to build the language out more, things like that. This could be critical in expanding machine translation globally. Using industry-specific models for certain translations would be another future direction. Also, reducing the bias and ensuring fairness when translating could be really important, as ethically we need to consider what language the machine translation is based on and how it can be better fair to all of the languages around the world. Also, integrating the translations into large language models for real-time contextual translation would be incredibly useful. Another future direction could be allowing humans and artificial intelligence to collaborate on translation, which could provide the artificial intelligence a chance to receive corrections from the humans. Um, Neural machine translations still struggle with producing the most accurate and fluent translations, so despite all of the growth that they have experienced over the last few years, it would still be important to perfect their machine translation capabilities. Also, evaluation metrics are important. There is currently no organized evaluation metric for deciding if a language model is good or bad, so it would be important to figure out some criteria to determine if language models are appropriately translating and evaluated correctly. And finally, robust machine translation can be improved. Slight changes to a sentence, such as a misplaced comma or even the different enunciations of words, could have a great meaning. Sarcasm, different emotions can be communicated through words. So slight changes in sentences could lead to great changes in the machine translation. So improving the error tolerance of machine translation systems could lead to much more improvement and global communication. So, in conclusion, machine translation has come a long way from the 1940s when it was just rule based into the neural machine translations and continuing up until today, where we are fixing some of the issues in machine translation and working towards future directions to make it even better. So, thank you so much for listening to my presentation on machine translation, what it is, the types of machine translation, the various issues with machine translation, and some future directions. Thank you.